Hi, Amaya. I am going to just go through a couple of these. It says to write the first 5 terms of each sequence and determine whether it's arithmetic, geometric, or neither. So with this first one, they're giving you the first term in each of the sequences. And so one of the things I like to do is like set up a table so that I can kind of see if I can enlarge this a little bit so that I can kind of see this as an XY table almost. So this would be my n and this would be my a of n, or my function notation. So with sequences, you're either going to start with a first term, so n is 1, or you're going to start with a 0th term, so n is 0, but you're never going to have a negative term or a fractional term. So it looks like this is starting with n is equal to 1, and then it's just the integers, positive integers after that. So I guess we don't need that 6th term, do we? Whoops. Anyway, so if a of 1 is 7, then it says here in the rule to take the previous term and subtract 3. So a of 2 would be 4, and then we're going to subtract 3 again, and we get 1, and subtract 3 again, and we get -2, and then the 5th term would be -5. Hopefully I did that correctly. 7 minus 4 is 3, minus 4 is 1, minus 3 is -2, minus 3 is -5. Okay. So that looks very arithmetic to me, and that's all we need to do then for that one. So this one would be arithmetic because there's a constant difference in that d, the difference here, d is equal to -3. Okay. So with the second one, and then the domain part, this part out here, if you have a question on that, what they mean by that is that what I was saying earlier. We don't want n to be fractions, and we don't want it to be negative. And in this case, since there's no 0th term, since this starts with a 1, we don't want it to be 0 either. So in order for that to happen and work in this formula here, we have to have it greater than or equal to 2. Because if I would put n equal to 1 in here, if I would put a 1 in for n, I'd get a sub 0, and there is no a sub 0 here in our sequence. It starts out with a first term, then a second term, and so on. In your Desmos activity, when you did 1.8 and that paper cutting, then you did have a 0th term because it was the whole sheet of paper before any cuts at all. So n was the number of cuts, and the area of that paper was 80 square inches at 0 cuts. So sometimes they start with 0 terms, sometimes they don't. And that's how you determine what this this domain will be. So this is your domain here. And domain, if you remember, is just the same as when you were talking about linear functions in Algebra 1. The domain is all the possible x values, and the range is all the possible y values. So, and you can think of this as x and y, kind of, basically. So the next one then, looking at that, if I made another table here, let's do it in a different color. So here's another table, and I'm going to put the term number on top, n, and b of n this time. The function is named b of n. That's going to be on the bottom. So we have 1, 2, 3, 4, and 5 terms again. And the first term, it says, is 2. So now we're going to let n is equal to 2, greater than or equal to 2. To find the second term then, we're going to multiply the first term, n minus 1 is 1, So if we're finding if n is 2, 2 minus 1 would be b of 1, and we know that to be 2. So we would take 2 times 2. This is equal to 2 now if n is equal to 2. And then subtract 1. So it'd be 4 minus 1 is 3. And then do it for n equal to 3. Now we'd put a 3 in here. And so it's telling us to take 2 times the previous term, which would be n of 2, or b of 2, which is 3. So it's 2 times 3, that's 6, and then subtract 1, we'd get 5. And then the fourth term, we'd put a 4 in here. And it says to take 2 times the previous term. 4 minus 1 is 3, so b of 3 is 5. 2 times 5 is 10, minus 1 is 9. And then finally, put a 5 in there for n to get the fifth term. And we would take 2 times the fourth term then, because 5 minus 1 is 4. So 2 times 9 is 18, and then we always have to subtract that 1, so we get 17 out there. So that's how that works. And this one, in this case, here you're adding 1, then you're adding 2, then you're adding 4, then you're adding 8. So this is neither, because there's no common difference. Up here we said the domain was, or the difference was -3. Down here, it changes each time. And so if it's not the same number that you're adding each time, we can't count it as arithmetic. Otherwise, it looks arithmetic, just like the first one. Then for letter C, the function C, do the same thing. So build your table. So we'll put n on top and C of n on the bottom. That's like our x and y. So if n is 1, 2, 3, 4, and 5, then we have, if n is 1, we are told, whoops, that C of 1 is 3. So that's good, because we can't put a 1 in there. So then to find 2, the second term, we would put a 2 in there, and it tells us to take 10 and multiply it by the first term. So this would be 30 then. And then if n is 3, that's telling us then to take 10 times the second term, which is 30. So then we would have 300. And this is just going to keep getting multiplied by 10. Okay? So this is geometric because we're multiplying for one thing, and we're multiplying by the same ratio, same 10. So this would be geometric, and R would be 10. And finally, the last one here, make it orange. Our function D, we'd have n here and d of n here. And then we've got 1, 2, 3, and 4, and 5 terms. And then if you put 1 in for D, or for n, I'm sorry, we get 1 back out, because that's how the function is defined. The first term is 1. Now if we put 2 in for n, that tells us to take n, which would be 2, times d of n minus 1. Well, d of 2 minus 1 is d of 1, and d of 1 is 1. So we're going to take 2 times 1, and that'll give us 2. And the next one, to find d of 3, we put 3 in here and here, according to our rule. And so we're going to take 3 times d of 3 minus 1. D of 3 minus 1 is d of 2 here, so that would be 2. So 3 times 2 is 6. So basically, we're just multiplying the term number by the previous term. And so d of 4 is going to be 4 times 6, which is 24. and d of 5 is going to be 120 then. So this one, since you multiply by 2 here, and then you multiply by 3, and then you multiply by 4, and then you multiply by 5, there's no common ratio, so this is a neither also. So you can define functions that are neither arithmetic nor geometric using a recursive rule, but it won't follow a geometric or a arithmetic pattern. So this one is arithmetic and this one is geometric. The other two are not, but they can all be defined using a recursive rule. And that's what these are in the circles there. So hopefully that helps. And if you have any further questions, please just email me or stop in. I'll be in my office hours from 1 till 3 tomorrow. So thank you.